we're going to be, oh, sorry about that, I got too excited. For this experiment, we are going to be exploring the powers of different temperatures of water to dissolve substances. So I'm going to show you guys my workstation so we can get all of our materials ready to go. So you only need a couple of things from this experiment. One thing you will need from the store are these magic grow capsules. You can probably find them at the supermarket. They're usually pretty cheap and pretty available. You can see here, they're just these little colorful capsules that you dissolve in water. So we are going to be doing that today, but with a twist. So what we have here are 2 different glasses of water with different temperatures. So you're going to need a glass of cold water and then a glass of hot water. It doesn't have to be super hot. It can just be a little bit warm. Just make sure they're different temperatures because that's going to be the magic of this experiment. So to do this experiment, you're going to go ahead and open up the packet of grow capsules. And take out 2 of them. They're all going to be surprise creatures. So we'll see what we get. So we have our 2 grow capsules. I have my cold water on this side and my warm water on this side. So we're going to test and see how well the different temperatures of water are able to dissolve these capsules. And then I'll tell you guys a little bit about why we're seeing the results we're seeing. So go ahead and put one of the capsules into your cold water and one of the capsules into your warm water. And they kind of float and they'll take a minute to dissolve. You can kind of press them down if you want them to go a little bit faster. And now we wait. So a little bit about grow capsules. They're made with a substance called gelatin. Gelatin is odorless, tasteless, and colorless. So this is the main ingredient in Jell-O. So you might have eaten it before. The flavor that you taste when you eat Jell-O isn't the flavor of gelatin itself. It's the added flavorings that they put in there to make it tasty, because otherwise it just tastes like a whole lot of nothing. So gelatin is made of a substance called collagen, and collagen actually comes from animals, or it can be made in a factory. It's a protein that is sometimes made from the skin, connective tissue, or bones of animals like cows. So inside each of these capsules is a sponge creature. So there's the clear casing of gelatin, and then there's a little foam creature that's all balled in there. We'll check on these guys. Haven't started growing yet. We'll give them a couple of minutes. So when the capsule dissolves, what's going to happen is the water is going to enter into the foam creature on the inside and fill it up and expand it. So it'll kind of pop out. If anyone has ever done these before, they're super fun and you'll get to see that happen in a couple minutes. They're a little sticky at this point, you might have noticed. For me, when you're a scientist, it's very important to notice the different things that happen in your experiment. So right now I want to notice the fact that this one in the cold water, it feels kind of the same. It's not really changing so much yet. And then this one in the warm water has gotten really sticky. And if you can see mine, the little guy is like starting to come out the very beginning. So this one's dissolving. Another part of being a scientist is being very patient and having to wait for you to get your results. So some of our experiments are really quick, like the lemon volcano, and you see it happen right away. And then some of them like this, you have to be very patient and make your observations. Oh, so this one, I don't know if you guys can see it, but the capsule is starting to dissolve. Got some movement. And still over here with the cold one, nothing has happened. I could take this out and put it back in the box, and I'm pretty sure it'd still be the same.
Can I ask you a question, Miss Lexi?
Of course.
When you did the water in each cup, did you just use the hot side of your sink for the one cup and the cold side for the other, or did you do something else?
That is a great question. You can do it either way. You'll get more extreme results if you do it with colder water and warmer water. So what I did was take a little bit of water out of the tap on the cold side and then put just like not full ice cubes, but a tiny, tiny bit of ice in there to drop it down a little bit more to get it a little bit colder, to be a little more extreme. And then with the hot one, I boiled the water till it was just boiling and then kind of let it sit for a little bit. So if you want the more extreme side of the experiment, definitely ask an adult to help you out with boiling the water, with getting the ice cubes and getting all that set up, or you can just do it by yourself and use the cold side and the hot side of the tap, and that should be enough for you to get different results. So at this point, it's pretty clear that we're still waiting for them to pop out, but we do have some results. So we can see that the cold one has not done anything to the capsule. The capsule is still totally intact and our little creature is still in there. If you touch it, mine is just starting to get sticky, and that means it's just starting to dissolve, whereas this one is almost fully dissolved. So what we know from these results is that hot water or warm water dissolves gelatin a lot better than the cold water. So in general, things dissolve a lot faster in hot water compared to cold water because hot water has more energy in it. So there was energy that was used to actually heat up the water. If you boiled the water like I did, it was the energy coming from your kettle into the water that actually heated it up. And if you got it from your pipes on the hot side of your tap, it's the same thing because on the inside of your pipes, you have what's called a water heater. And that's why the water comes out hot. So what's happening in both those cases is we're using electricity to raise the temperature of water from room temperature up to being hotter. So that energy doesn't go away. It stays in the hot water. And what happens when you put something in it that can dissolve is that energy is causing all the water molecules to bounce around. So when the water molecules bounce around, they hit whatever is in it, and that leads to it breaking down. So when we put the gelatin capsule into the hot water, those water molecules were bouncing around like crazy back and forth, hitting the gelatin and causing it to dissolve. That's why this one is almost done and this one has barely started. So cold water, you might be thinking cold water also has energy in it because we use energy to make ice, we use energy to freeze water. So why isn't that energy working the same way in the cold water? And that's because when energy is used to drop the temperature of something, it's actually slowing the water molecules down. And if it's freezing, it's actually slowing the water molecules down so much that they solidify. And that's why we get ice. So as opposed to the molecules in the hot water that are bouncing around really quickly and hitting the capsule, the molecules in the cold water are moving even slower than they would at room temperature. So they're hitting the capsule less and less and with less force. So it's not dissolving as quickly. And like I said earlier, if you get the water molecules moving slowly enough, in this one, it'll completely freeze. So that's why we get boiling water, and that is why we get ice. And my little guy is almost out. Oh, it's really sticky. I don't know if you can see it on my finger, but it's like fully, this is kind of what we mean when we talk about gelatin. It's like very, very goopy. And let's check this one. A little sticky, but not goopy. Eventually, this one will work and it will dissolve, just way, way, way slower. And if you actually look in the instructions on one of these, it says to use warm water for that very reason. So mess around with this, play with the temperatures and see what you get. You can also add energy in other ways, like if you take a stick and you stir it, that's going to add that energy from your hand into the water. So you're agitating it, and that'll be hitting the capsule, adding energy and causing it to dissolve faster. So try 2 with the same temperature of water, one where you're stirring it and one where you're not, and see what you get. So I don't know if anyone else's little creatures have come out yet, but mine have not, but I'm happy to answer any questions about them.